bunch of this, we're going to go really fast at the beginning because this is basic exponent laws that you've covered in grade 8 and 9, I think. I don't know, maybe 7 you started? I don't remember. I don't know the new curriculum very well for junior high. Okay, so when we have exponents, I'm going to grab a little highlighter here. Whole number exponents where the base is a numerical value. So we have a base and then we have an exponent, right? 2 to the power of 3, we call 2 would be the base. 3 is the exponent for this power. So that's terminology. So we're going to review our basic exponent laws that you've learned before, and then before we extend into more things. So the concept of, right, 2 times 2 times 2, we can write that as 2 cubed. That would be exponential form as instead of repeated multiplication. We pretty much never write things like that except for with prime factorization. We want to write it as 2 cubed. Okay. So let's move on. Here's base, exponent. This is the power, right? We just talked about that. So here, what's my base in this first example? 4. What's my exponent? 5. What would be my base here? -3. Good. Exponent? 6. And base? X. Exponent? Y. Okay? Let's turn the page. Okay. Oops, go back. State the coefficient each of the following. So a coefficient, right, is the numerical value that's being multiplied. That's in front. So what would be the coefficient here? 8. B would be -3. What would C be? Not 7. Nope, not A, because A is the base. 1 over. So we can actually write this instead. When you divide by 7, it's the same thing as multiplying by 1/7. So we can write this as 1 over 7, A to the power of 8. That's another way to write it. It's the same thing. If you multiply by a half, it's the same thing as dividing by 2. So dividing by 7 is the same as multiplying by 1 over 7. The coefficient, if you don't see it on the numerator, is a 1. So the numerator is a 1, the denominator is a 7. So your coefficient then would be 1 over 7. Okay. In fact, we usually actually want to write it like this, 1/7, A to the power of 8. Okay, we're skipping that. Or do we need to? Well, okay, I'll do 1. Write each of the following as a repeated multiplication. So you would write this as 3. How many A's are being multiplied? 4. Gentlemen, can you get this down? And how many B's? 1. Okay. Should we do one more? Maybe. Which one? Pick one. C, D, or B. Which one are you most unsure about? D. Okay. So 3AB to the power of 4. That means it's the same thing as 3AB multiplied by 3AB how many times? 4 times. Could you rewrite that another way if you wanted to? Sure. So we could write that as 3 times 3 times 3 times 3. Learn how. A times, whoops, miss my times. A, B times B times B times B. There you go. Got it? Okay? All right. So, anything to the power of 0 is not 0, 1. I know, it's like crazy because most things, when you do anything with 0, right? Times 0, divide by 0. Anything to the power of 0 is 1. So, let's do some of these guys here. 6 to the power of 0 would be 1. -9 to the power of 0. just 1, okay? Because it has brackets, the whole thing is to the power of 0. It's 1. Now, are B and C the same thing? No, this is essentially like saying -1 times 9 to the power of 0. Only the 9 is raised to the exponent. The negative is not. If it was, it'd be in brackets. So 9 to the power of 0 is equal to, so if I just looked at just solving this guy, 9 to the power of 0, that's equal to 1 times the -1 is -1. So this is -1 times 1, which is -1. Okay? So if you have a -9 to the power of 0 and it's not in brackets, that would actually equal -1. So this part, oh, that's not a highlighter. Right here. So what's raised to the power of 0? This part, right? So that would equal to, the answer would be 2, because 2 times, this is anything to the power of 0 is 1. 2 times 1 is 2. Okay, so your exponent laws. Let's get into those. Okay, you've seen these before. Hopefully they're fresh in your mind because they're kind of expected knowledge. So when we have the same base being multiplied, okay, you could write that out as repeated multiplication. You can see that there's 5, if there's 3 8s and then 2 8s, it's a total of 5 8s. So we add the exponents. So when we have the same bases being multiplied, we add the exponents. What do they want from me here? 3 plus, oh, I think they're saying want me to write 5 or 3 plus 2. The same basis being multiplied, that's the product law. Then we have the quotient law. So if we have the same basis being divided, so if I have 3 8s divided by 2 8s, what happens is a bunch of these 8s will cancel each other out. And so that's why you're equal to just 1. We subtract the exponents. 3 minus 2 gives you 1. Okay, so say this would be 1 as well. 3 minus 2 would give you 1. These a's cancel out. And so when you have the same basis being divided, we then subtract the exponent, and that's the quotient law. Do you remember these? Okay, product of a power of a product law. So I'm just going to write the law first. So what this means is if you have a times b to the power of m, that's a to the m and b to the m. The power applies to both of those inside. Okay, so here they had 8 times 7 to the power of 3. So we have 8 times 7, 8 times 7, 8 times 7, or 3 8s and 3 7s. So that's how you get 8 to the 3 and 7 to the 3. So this would be b times b times b, or a cubed and b cubed. Okay. We're mostly only working with variables in Math 10. So you're not going to be dealing with exponent laws. Maybe just for some intro and some of your homework, you'll have a little bit. But pretty much everything is we're going to be working with the variable bases. Okay? Now, unlike when you had just number bases before. So the power of the quotient is same idea, power of product. That exponent applies to both the numerator and the denominator. So if you had 8 over 7 cubed, so it'd be 8 over 7 times 8 over 7 times 8 over 7. Or on the numerator, you have 3 8s. On the denominator, you have 3 7s. A over B, A over B, A over B. A cubed over B cubed. And the last one is the power of a power. So if you have, what do we do with that? We have an exponent, a base raised to an exponent raised to another exponent. We multiply them, okay? We multiply. So we have 8 cubed. So if I have 8 cubed all to the power of 2, that's the same thing as 8 cubed times 8 cubed. or 8 to the 6, 3 times 2, right? 3 times 2. And we'll write this out. It's very tedious. So 8 to the power of 6, 3 times 2. Okay, let's turn the page. So those are your exponent laws. That should be reviewed. Let's do a couple examples, and then we'll move on to the next lesson. And you'll see why we're moving on, because this should be easy, right? No? I don't know. Like the first one, what do we do? Same bases being multiplied. We add them. So 3 to the power of 4 plus 2, or 3 to the power of 6. Same bases being divided. We subtract. 5 minus 3, or 2. And last, 5 to the power of 2 to the power of 3. We multiply them. 2 times 3, or 5 to the power of 6. Okay, so let's do the same thing. Well, why don't you try right now A, B, C, D, E, and F. Okay, try those ones, and then we'll leave the bottom ones to do together. First one, A to the power of what? 7. 4 plus 3, because the same bases are being multiplied. What would be the next one? So if we don't see the exponent, what's the exponent?
1.
A 1, so 6 plus 1 gives you 7. Again, we're multiplying, same basis, so we can add the exponents. 11. B to the power of 0 is just 1, so you could just, if you wanted to change that to a 1, you could, and then combine the 7 and 4, or just add 7 plus 0 plus 4. That works too. Okay, same basis being divided, what would we do? Power of 4, subtract. This become y to the power of 8, 10 minus 2, and a to the power of 4 times 3. Power to a power, we multiply. Okay? Coming back to you? Pretty simple? Hopefully. Okay, so what would be, this one should be easy too. 25, 5 times 5, power to a power. How else could we write h? x9 over y9. So we can apply that to both of them. Actually, we would, right? It applies to everybody inside. So same idea here. This would become c squared over 4 squared, which we would want, whenever we have a number, a base that's a number to an exponent, you want to actually evaluate it. We need to figure out what number that is, okay? Don't leave it as 4 squared. 4 squared is 16, okay? So that's if you have a base that's actually a numerical value, evaluate what it is to the exponent. How else could you write j? Good. So it applies to everybody inside. Both of them get to the power of 6. So this guy would be, okay, so 2 to the power of 5 times a to the power of 5. That 5 has to apply to everybody inside, but when we have a base that's a number, we're going to evaluate it. And 2 to the power of 5 is 32. Thank you. Okay, so same idea here. What you would want to do in this case is when I apply the power of 4 to everyone, including the negative 3, I'm going to leave that negative 3 in brackets, right? We had focus. I am recording. You're going to be famous. Okay. So we want to leave it in brackets. Remember we talked about earlier, negative 3 to the power 4 is not the same thing as negative 3 in brackets to the power 4, right? But because the negative is inside the brackets, it's also raised to the exponent. So you want to keep that inside brackets. So if it was, this negative was on the outside, then we wouldn't. And whenever you raise a negative to the power of a even exponent, what does that equal? A positive. Remember, if you have 4 negatives, equals a positive. So negative 3 to the power 4 is a positive 81. And you could see in your calculator, you would want to have the brackets. Because if you don't have the brackets, oops, 4 versus 4. See the difference? Difference. One gives you the right answer, one gives you the wrong answer. So you want to have those brackets. Okay? So that's it for this part. Do you see how we're like, move on? It's just applying the exponent laws again in lesson 2. So we're going to move on to lesson 2. And then we can go slower tomorrow with the new stuff. So this is on page 71. Okay, we're going to skip the warm-up and go straight into working through some of these. We won't do every single one. But when we're multiplying, so if I'm multiplying 4x to the 5 times 2x to the 2x cubed, we want to multiply the coefficients and then multiply the same bases. So if I was showing like going really slow, I would write this instead as 4 times 2 times x to the 5 times x to the cube. Because with multiplication, these like 4x to the 5 is just 4 times x to the 5, right? And with multiplication, you can do things in any order if it's all multiplication. 2 times 3 times 4, let's say, okay? I could first go 2 times 3, which is 6 times 4, 24. Or I could have first gone 3 times 4, oops, 2 times 12, which is 24, right? So the order doesn't matter. It's going to give us the same result. So we multiply the coefficients, which is 8, and we get x to the power of what? Add the exponents, because they're the same base. So let's go to C. For dividing, we divide the coefficients. So 20 divided by 5 is 4. And when you're dividing same bases, what do we do with our exponents? Subtract, so it'd be 15. Okay? Well, let's try 30, or D, 30 over 45. Okay, will 45 go evenly into 30? No, but can we reduce it? Yeah, and if you have a graphing calculator, your calculator can reduce it for you too. How would it reduce? So 30 divided by 45, and then what would I push? Any guesses? So math, enter for a fraction, and enter. It'll reduce a fraction. So you just take your fraction, and then go math, enter, enter, and it reduces it for you. Isn't that nice? So you first type in 30 divided by 45, and then we push math, enter, enter. 2/3. So this is going to reduce to 2/3, or we can just write 2/3, or reduces to 2/3. And when you have the same base being divided, subtract, so that becomes B. Whoa, that's a weird looking B. B4. And so the 2/3, you could write this as 2b4 over 3, but we would normally just write it as a coefficient in front instead, as 2/3. Those are both the same thing. Okay? Let's move on to example 2. Let's start with B, and then we'll do C and D. Okay? So here, we're dividing, so the x's are the same base, becomes x to the power of what? Subtract them is 2. 5 minus 3. Y to the 4. 8 minus 4 is 4. Where would I start with C? So first we want to multiply the coefficients. So we have a -3 and a -4. What does that multiply to? Positive 12. Now we can do our B's. So the B's are, we have a B here, right? A B cubed. Oh, that's pretty dark. And a B squared. I'll undo that. I'll just underline them in red. Okay, so B cubed, B squared. So if there's no exponent, what's the exponent? 1. So it's going to become B to the power of what? 6. 1 plus 3 plus 2 is 6. And now my C's, I have a C to the power of 1, C squared, and a C to the power of 1. C4. Good. Yeah. Can you try D? So reduce 10 over 4. 5 over 2, so that would be your coefficient. 8 minus 4. 4. And 12 minus 7. 5. Good. Okay. You could have also had all over 2. That works too. Same thing. Okay, turn the page. We're getting there. I'm doing good for 10. Okay, let's do B and D in example 3. So this exponent 2 on the outside applies to who? Everything. So negative 2, what would we have to do with the negative 2? Brackets, so negative 2 to the power of 2. Uh-oh. Now, if I want to go step by step, I could just take my time. A squared to the power of 2 and B cubed to the power of 2. Now, some of you might go straight to the simplified form, and that's fine. Okay? Now, what happens when you square a negative 2? Positive 4. Now, if we have a power to a power, what do we do with that? Multiply it, so that equals, would have gave you the same thing? 4, in this case. And then b to the power of 6. Okay. I like C. There's a lot of x's there. So it's up to you how you want to simplify this. I'd probably simplify my numerator and my denominator first. So how could you write the numerator instead? If you have x to the cubed times x to the 5th, x to the 8th, we add those, and x to the 2 times x, this is a 1 if you don't see it, 3, and so that equals x to the 5. Okay. I know said we weren't going to do C, but we're distracted by it. Okay, so when you have a negative like this out front, you want to apply it to your coefficient. So I could rewrite this instead as negative 2a all over y cubed. Because otherwise it's kind of distracting. Because it belongs with the coefficient, right? When you're dealing with the negative, it belongs with the coefficient. So now, who does this power of 3 apply to? Everything. What do we have to be careful of? The negative needs to be in brackets with the 2. So that's going to be the power of 3. A will be to the power of 3. Because what is the exponent if you don't see it? A 1. And a power to a power, you multiply. Okay, divided by y to the power of 9. Power to a power, we multiply. So one more step. If you have a base that's a numerical coefficient raised to an exponent, we want to evaluate that. So in your calculator, you can type that in if you want. The negative is different than the minus sign. You have to use the negative. So if I tried to put the minus sign in front of the 2, your calculator would give you error. So negative 8. A cubed over y to the 9. Okay. Let's look at A. Should I make this larger for those at the back? I can zoom in. Is that better? That's better, isn't it? Okay, so what if there's a negative inside, but there's no coefficient? What is the coefficient? It's a 1, or negative 1 in this case. So I might want to rewrite that, because when I bring the power 5 in, and I'm applying that 5 to everything, I need to apply it to the negative 1 coefficient as well. So if we rewrite this, the 5 is being applied to both. So we have negative 1 to the power 5 times n to the power of 10. Okay? And when you raise a negative to an odd exponent, what does that equal? Positive or a negative? There's 5 negative ones. Think of it that way. Right? For every 2, that would equal a positive. So positive times a negative is a negative. So negative times negative 1 n to the power of 10. And 2 negatives make a positive. So if you can, you want to simplify before you bring in the exponent on the outside. If you can simplify in your brackets, let's do that. Can we simplify here? What can we simplify? Did you want to try this one on your own? No? Okay. So I see some steps. Like, let's the numerator. Let's simplify the numerator. 4 times 3. What can that become? 12. So I have 12. I'm going to write it alphabetically. X to the 6 y cubed divided by 6x to the 5. Okay, now what can we do? Coefficients. 12 divided by 6. So that becomes a 2. Anything else? The x's. We have x to the 6 divided by x to the 5. What happens if we have the same bases being divided? What do we do with our exponents? Subtract them. So 6 minus 5 is 1. X to the power of 1, y cubed. Now is that a lot easier to solve? So we took the x's and we subtracted them. Right? 6 minus 5. Okay. So who does the power of 4 apply to now? Everyone? 2 to the 4. What will x be to raise the power of now? 4. It's a 1, right? 1 times 4. And y to the power of 12. Or 16. Okay. I feel like you should try one. Why don't you try C?